Okay, so in this video we're going to start with one of the problems, and probably looks very similar. In this section, a lot of the shapes, the problems are going to be the same. So right off the bat, I tell you it's a hyperbola. So those are key things that you need to look for in problems, because when we take a test or a quiz, you're not necessarily going to know that it's a hyperbola. You might be given an equation or look for the key words. So we're going to write the standard equation for a hyperbola whose vertices are at -5, 0. So I know the vertices, which are on the major axis, or what we call the transverse axis, are at -5, 0 and 5, 0. Co-vertices are here. So the change in the vertices are on the x-axis. So that tells me right away that I'm dealing with the x squared over a squared minus the y squared over b squared is equal to 1. I'm going to go ahead and shrink this a little bit more. So that tells us what we're working with. So then that tells me that I know a is equal to 5 and b is equal to 6. Now in this one, the way that the hyperbola is set up, we use the equation a squared plus b squared is equal to c squared. So notice in an ellipse we had a plus here and it was a minus in the equation. In a hyperbola it's a minus, so it's a plus. So the formula is always opposite of that. So we need to find our focal points. We're going to go ahead and graph it. And I know the center is at the origin because the y value does not change and it goes from 5 to 5. So what's the middle of 5? What's the middle from -5 to 5? That's going to be 0. So if I even plotted these points, I would have a point right here. I'm going to erase these because I'm going to zoom in, and a point right here. The middle is right here at the origin. So we can even find midpoint, and that would tell us where the actual value is. And so that tells us that we're dealing with the center at 0, 0. So I know the center is at 0, 0. I know a is equal to 5. I know b is equal to 6. And real quick down here on the bottom left, I'm going to do a squared plus b squared is equal to c squared. So 25 plus 36 is equal to c squared. So c squared is equal to 61. And so c is about the square root of is the square root of 61. And in order to graph this, and that's a plus or minus, we're going to go in two different directions. The decimal value is approximately 7.8. So I know c, and that's, I'm just going to use that for graphing purposes, is square root of 61. So the equation is going to be x squared all over 25 minus y squared over 36, which is equal to 1. And notice a squared is less than b squared, and that's okay. That's different from our previous shape. So now I'm going to go ahead and graph this guy, and when I graph it, I'm going to go ahead and zoom in. I got the information right here, and I'm going to go ahead and plot my center first. So here's, disregard the dots that are on here. So here's the center, which is at 0, 0. I'm going to move out 5. So there's that guy, and there's that guy. 5 in both directions. So this guy right here is a vertex. This guy is also a vertex. I'm actually going to plot B. So I'm going to go up 6. So I go up 6 and down 6, because that's B. From the center, I'm going to shift 6. So I move down 6 units, and I move up 6 units. And that's going to give me my my vertices, co-vertices. Nothing goes through the co-vertices, but if we kind of line up, so notice if I kind of line up, so I'm going to draw a dashed line this way and a dashed line this way, I see the point of intersection here. And if I draw a line this way and draw a line this way, this is the point where the horizontal and vertical line meets. And if I do this all the way around, where the imaginary vertical line and not imaginary in the sense of imaginary terms, but what this box is used for is we have these asymptotes that I showed you that help kind of create our shape. And so the vertices of this rectangle that's created, the opposite vertices actually is where we draw. These are the points that the asymptote that we're supposed to draw touch. This tells us, these asymptotes tell us how wide we're supposed to graph our hyperbola. And so notice the hyperbola is going to stretch and be attracted to that asymptote. And that's how we can see how kind of wide or narrow the actual hyperbola shape is going to be. And this plus or minus root 61, I told you earlier, it's about 7.8. So I'm going to go ahead, and this was already 5, so 7.8 is going to be about right here. So here's my focus. Negative 7.8 is going to be about right here. Here's my other focus. So I've plotted all my points, and I'm going to go ahead and I'm going to shrink this a little bit, and that's our shape. And I'm going to go ahead and identify all the different things. So I've already identified my, oops, sorry about that. I've already identified my center. So my vertex was already given, so it's plus or minus 5, 0. My covertex, 0 plus or minus 5. And my focal points are going to be on the x-axis from the center, so plus or minus root 61, 0. And those are all the points that we had to graph. So we'll talk more about how to get these equations of the asymptotes in more detail, but this is our very first example. In order to get the actual asymptotes and draw them, we create this box of vertical and horizontal lines that are created by the intersection of where the vertice points are and where the covertice points are. And so that's how I can create this box to trace my asymptotes.